TeamCity Online Training. Introduction to TeamCity. TeamCity is a continuous integration and continuous deployment (CI/CD) server developed by JetBrains. It is designed to help teams build, test, and deploy code more efficiently. Here's a brief overview of its key features and functionalities. Key features of TeamCity: continuous integration and continuous deployment (CI/CD). Automates the process of integrating code changes and deploying applications. Supports various version control systems like Git, Mercurial, Subversion, and more. Build management. Provides extensive build management tools, including build history, change tracking, and build queue optimization. Supports different build tools and environments such as Maven, Gradle, and an MS Build. Build agents and build grid. Distributes builds across multiple build agents to balance the load and speed up the build process. Supports a build grid that can dynamically allocate build agents based on the current demand. Extensive plugin ecosystem. Offers a wide range of plugins to extend functionality, including integrations with popular tools like Docker, Kubernetes, and AWS. Custom plugins can be developed to meet specific needs. Test automation. Supports automated testing frameworks and provides detailed test reports. Allows parallel test execution to speed up the testing process. Build and test history. Maintains a comprehensive history of builds and tests, including logs, artifacts, and change details. Provides insights into build performance and stability over time. Build configuration and templates. Allows creating build configurations and templates to streamline the setup of new projects. Supports parameterized builds for flexible and reusable configurations. Benefits of using TeamCity. TeamCity, a continuous integration (CI) and continuous delivery (CD) server developed by JetBrains, offers a wide range of benefits for software development teams. Here are some of the key advantages. 1. Comprehensive CI/CD capabilities. TeamCity supports the full CI/CD pipeline, allowing teams to automate the build, test, and deployment processes, thus improving the speed and reliability of software delivery. 2. Ease of setup and use. The setup process is straightforward, with a user-friendly web interface. It offers out-of-the-box configurations for many popular technologies, making it easy to get started. 3. Integration with multiple tools. TeamCity integrates seamlessly with various development tools, version control systems, example Git, Subversion, Mercurial, and cloud services, example AWS, Azure. It also supports integration with popular issue trackers like Jira and UTrack. 4. Build chain and dependency management. It allows for the creation of complex build chains with dependencies, ensuring that builds are triggered in the correct order and that the entire pipeline runs smoothly. 5. Real-time feedback and notifications. TeamCity provides real-time feedback on the status of builds and tests, allowing developers to identify and fix issues quickly. It also supports notifications via email, Slack, and other communication tools. 6. Extensibility and customization. The platform is highly extensible with a wide range of plugins available. It also allows for custom scripts and configurations to suit specific project needs. 7. Parallel and distributed builds. TeamCity supports running builds in parallel across multiple agents, optimizing resource usage and reducing build times. Distributed builds allow for better scalability and performance. 8. Powerful build configuration. With advanced build configuration features such as templates, parameters, and snapshot dependencies, TeamCity offers flexibility in defining and managing build processes. 9. Comprehensive test reporting. It provides detailed test reports and insights, including flaky test detection, to help teams maintain high code quality and reliability. TeamCity versus other CI/CD tools. When comparing TeamCity to other continuous integration, continuous deployment (CI/CD) tools, several factors should be considered: features, ease of use, scalability, integration capabilities, and cost. Here's an overview comparing TeamCity with some popular CI/CD tools. TeamCity. Pros. Comprehensive feature set, supports build chains, multiple build configurations, and dependencies. Integration, extensive plugins for various tools and technologies like version control systems, Git, Mercurial, build tools, Maven, Gradle, and more. Configuration, both web interface and code-based configuration, Kotlin DSL. Build history and reporting, detailed build logs, history, and customizable reports. Distributed builds, ability to distribute builds across different agents. Free tier, free version available for smaller teams. Cons. Complex setup, can be complex to set up and configure for beginners. Cost. Enterprise features can be costly for larger teams. Jenkins. Pros. Open source, free and open source, with a large community. Extensive plugin ecosystem, thousands of plugins for almost any integration or customization need. Scalability, highly scalable with master agent architecture. Flexibility, highly customizable through scripting and plugins. Cons. Maintenance, requires significant maintenance and manual setup. User interface, the user interface can be clunky and less intuitive compared to newer tools. Learning curve, steeper learning curve due to extensive customization options. Integration with TeamCity. TeamCity is a powerful continuous integration (CI) and continuous deployment (CD) server developed by JetBrains. It offers a range of features for automating the build, testing, and deployment processes of software projects. Here are some key aspects and benefits of using TeamCity for CI. Key features. Build configuration. Create and manage build configurations with ease. Support for various version control systems like Git, Subversion, Mercurial, etc. Custom build steps using different build runners, example Maven, Gradle, MS Build. Automated testing. Integration with testing frameworks, example JUnit, NUnit, TestNG. Run unit tests, integration tests, and UI tests as part of the build process. Collect and display test results with detailed reports. Build pipelines, Define build pipelines for complex workflows. Trigger builds based on changes in version control, schedule times, or manually. Chain builds and set up dependencies between projects. Build agents. Distribute builds across multiple agents for parallel execution. Dynamic agent management with support for cloud-based agents, example AWS, Azure. Agent pools for managing different types of builds. Artifact management. Store and manage build artifacts for future use. Publish artifacts to various repositories, example Nexus, Artifactory. Continuous integration with TeamCity. TeamCity is a powerful continuous integration, CI, and continuous deployment, CD, server developed by JetBrains. It offers a range of features for automating the build, testing, and deployment processes of software projects. Here are some key aspects and benefits of using TeamCity for CI. Key features. Build configuration. Create and manage build configurations with ease. Support for various version control systems like Git, Subversion, Mercurial, etc. Custom build steps using different build runners, example Maven, Gradle, MS Build. Automated testing. Integration with testing frameworks, example JUnit, NUnit, TestNG. Run unit tests, integration tests, and UI tests as part of the build process. Collect and display test results with detailed reports. Build pipelines. Define build pipelines for complex workflows. Trigger builds based on changes in version control, schedule times, or manually. Chain builds and set up dependencies between projects. Build agents. Distribute builds across multiple agents for parallel execution. Dynamic agent management with support for cloud-based agents, example AWS, Azure. Agent pools for managing different types of builds. Artifact management. Store and manage build artifacts for future use. Publish artifacts to various repositories, example Nexus, Artifactory. Notifications. Configurable notifications via email, Slack, and other channels. Customizable notifications based on build status, failures, and other events. Integration. Integrates with popular tools like Jira, GitHub, Bitbucket, and more. API support for custom integrations and automation. Best practices for TeamCity. TeamCity is a powerful continuous integration, CI, server that supports building and deploying projects. Here are some best practices to follow when using TeamCity. 1. Organize projects and build configurations. Hierarchy. Use a clear project hierarchy to keep related build configurations together. Templates. Use templates to avoid duplication of build steps and settings. Metarunners. Use metarunners to encapsulate complex build logic. 2. Efficient build agents management. Agent pools. Use agent pools to group build agents logically, example by project or department. Agent requirements. Define agent requirements to ensure builds run on appropriate agents with the necessary capabilities. 3. Version control integration. Branch specifications. Use branch specifications to handle different branches efficiently. VCS triggers. Configure VCS triggers to automatically start builds on code changes. 4. Build configuration and optimization. Incremental builds. Use incremental builds to reduce build times by only building what has changed. Build chains. Configure build chains to manage dependencies between build configurations. Parallel builds. Run builds in parallel where possible to speed up the overall process. 5. Testing and quality assurance. Automated tests. Integrate automated tests, unit, integration, UI tests into the build process. Test results reporting. Utilize TeamCity's reporting tools to monitor test results and trends. Static code analysis. Incorporate static code analysis tools to enforce coding standards and detect issues early. 6. Deployment and release management. Build artifacts. Manage build artifacts efficiently, storing only what is necessary. Deployment configurations. Use deployment configurations to automate the deployment process to various environments. 7. Monitoring and maintenance. Build history and logs. Regularly monitor build history and logs for any issues or patterns. Resource usage. Monitor resource usage, CPU, memory, disk space of build agents and the TeamCity server. Regular updates. Keep TeamCity and its plugins up to date to benefit from the latest features and security fixes. Setting up build triggers and dependencies. Setting up build triggers and dependencies in TeamCity is crucial for automating your CI/CD pipeline. Here's a step-by-step guide to help you configure these features. Build triggers. Build triggers in TeamCity define when a build should start. Common triggers include VCS, version control system, triggers, schedule triggers, and others. 1. VCS trigger. This trigger starts a build when changes are detected in the version control system. Navigate to your project. Go to the TeamCity dashboard. Select the project you want to configure. Access build configuration. Click on the build configuration for which you want to set up the trigger. Configure triggers. Go to the Triggers section. Click Add New Trigger. Select VCS trigger. Configure the VCS trigger settings, such as trigger a build on each check-in, start a build for every check-in. Quiet period. Wait for a specified time after the last change before starting the build. Click Save. 2. Schedule trigger. This trigger starts a build at specified times. Navigate to Triggers. Go to the Triggers section of the desired build configuration. Click Add New Trigger. Select Schedule trigger. Set schedule. Configure the schedule settings, such as cron expression. Define the exact times to trigger the build. Time zone. Specify the time zone for the schedule time. Click Save. Build dependencies. Build dependencies ensure that certain builds are completed before others start. This is useful for managing complex projects with multiple components. 1. Snapshot dependencies. Snapshot dependencies ensure that builds of dependent configurations use the same sources from version control. Navigate to Dependencies. Go to the Dependencies section of the build configuration. Add dependency. Click Add New Snapshot Dependency. Select the build configuration to depend on. Configure options like Run build on the same revisions. Ensure all builds use the same VCS revision. Click Save. Security features in TeamCity. TeamCity, a popular continuous integration (CI) and continuous deployment (CD) server developed by JetBrains, offers a variety of security features to ensure the integrity, confidentiality, and availability of your CI/CD pipelines. Here are some of the key security features in TeamCity. Authentication and authorization. User authentication supports various authentication methods, including built-in authentication, LDAP, and third-party services such as GitHub, GitLab, and Bitbucket. Supports single sign-on, SSO, via SAML 2.0. User roles and permissions. Granular user roles and permissions to control access to projects, build configurations, and other resources. Ability to define custom roles and assign permissions at different levels, global, project, and build configuration levels. Secure communication. HTTPS support. Configurable to use HTTPS for secure communication between the TeamCity server and users. Supports SSL/TLS certificates for encrypted communication. Agent-server communication. Secured communication between the TeamCity server and build agents using HTTPS. Ability to configure agent authorization tokens for secure agent registration. Data security. Secure storage. Secure storage of sensitive data such as passwords, tokens, and other credentials in encrypted form. Ability to integrate with external secret management tools. Backup and restore. Provides mechanisms for regular backup of the server and project configurations, ensuring data can be restored in case of any issues. Integrating TeamCity with other tools. Integrating TeamCity with other tools is a key part of building a seamless continuous integration (CI) and continuous delivery (CD) pipeline. TeamCity supports a wide range of integrations, enabling it to work with various version control systems, build tools, testing frameworks, deployment platforms, and more. Here are some common integrations. Version Control Systems (VCS). TeamCity integrates with various VCS to monitor changes and trigger builds. Git integration with Git repositories, example GitHub, GitLab, Bitbucket. SVN integration with Subversion repositories. Mercurial integration with Mercurial repositories. Perforce integration with Perforce Helix Core. Build tools. TeamCity can work with different build tools to compile and package applications. Maven support for building Java applications using Maven. Gradle integration for building Java applications using Gradle. Ent support for Apache and build automation tool. MS Build integration with MS Build for .NET applications. Testing frameworks. TeamCity integrates with various testing frameworks to automate the execution of tests. JUnit for running unit tests on Java projects. TestNG, another popular Java testing framework. NUnit for running unit tests on .NET projects. Selenium Integration for running UI tests with Selenium. Deployment tools. TeamCity can be integrated with deployment tools to automate the deployment process. Octopus Deploy, seamless integration for deployment automation. Kubernetes, support for deploying containerized applications to Kubernetes clusters. AWS, integration with Amazon Web Services for deploying applications to AWS. Azure, support for deploying applications to Microsoft Azure. How can you configure build agents in TeamCity? Configuring build agents in TeamCity involves several steps to ensure they are properly set up and connected to your TeamCity server. Here's a general outline of the process. Install build agent software. Download the TeamCity build agent software from your TeamCity server. This can be done by accessing the server's web interface and navigating to the Agents tab where you can find a link to download the agent installer. Install the build agent software on the machine where you want the build agent to run. Follow the installation instructions provided by TeamCity. Configure build agent properties. During installation or after installation, you will need to configure the build agent properties. This usually involves specifying the TeamCity server URL, authentication tokens or credentials to connect to the server, and any specific settings such as agent name, authorization details, and connection details like proxy settings if needed. Authorize build agent. Once the agent is installed and configured, it needs to be authorized on the TeamCity server. This involves adding the agent to the server's list of authorized agents. You can typically do this from the TeamCity web interface under the Agents section. Test agent connection. After authorization, restart the build agent service to ensure all settings take effect. Then, check the TeamCity web interface to confirm that the build agent appears as connected and online. This verifies that the agent can communicate properly with the server. Configure agent requirements and capabilities. TeamCity allows you to specify requirements and capabilities for build agents. Requirements are conditions that must be met for a build to run on a particular agent, example, specific software installed. Capabilities are attributes of the agent, example, installed software versions, that TeamCity can use to select an appropriate agent for a build. Configure build agent pools, if applicable. Build agent pools allow you to organize agents into groups, which can help in managing access control and distributing builds across different agent groups based on specific criteria. Monitor and maintain build agents. Regularly monitor the status of build agents from the TeamCity web interface. Ensure that agents are online, have sufficient resources, and are properly utilized. Perform maintenance tasks such as updates and configuration changes as needed. How do you manage projects and build pipelines in TeamCity? Managing projects and building pipelines in TeamCity involves several key steps. Creating projects. Start by creating a new project in TeamCity. Projects act as containers for your build configurations and related settings. Setting up version control. Connect your project to a version control system, VCS, such as Git, Subversion, or Mercurial. This allows TeamCity to monitor changes in your codebase. Creating build configurations. Within each project, Define build configurations. These configurations specify what actions TeamCity should take when building your project, such as compiling code, running tests, and deploying artifacts. Configuring build steps. For each build configuration, configure build steps that define the sequence of actions to perform during a build. These steps can include compiling code, executing scripts, running tests, and packaging applications. Defining build triggers. Specify triggers that start a build automatically based on events such as code commits, schedule times, or dependencies on other builds. This ensures that your builds stay up to date with the latest changes. Setting up dependencies. Configure dependencies between builds if your project has multiple modules or components that need to be built in a specific order. Adding build features. TeamCity supports various build features like code inspections, artifact dependencies, and notifications. Customize your build configurations with these features to enhance functionality. Managing build agents. Configure build agents to execute build configurations. Agents can be distributed across different machines to handle concurrent builds efficiently. Monitoring and reporting. Monitor build statuses, logs, and test results through TeamCity's web interface. Utilize reporting features to gain insights into build performance and trends over time. Integrating with external tools. TeamCity integrates with a wide range of external tools and services for testing, deployment, and reporting. Leverage these integrations to streamline your CI/CD pipeline. Why choose Proexcellency for TeamCity Online Training? Choosing Proexcellency for TeamCity Online Training can be advantageous for several reasons. Expertise and experience. Proexcellency likely offers training conducted by experienced professionals who are well-versed in TeamCity and continuous integration practices. Comprehensive curriculum. Their training programs often cover a wide range of topics, from basic to advanced concepts in TeamCity, ensuring thorough learning. Interactive learning. They may employ interactive teaching methods, including hands-on exercises and real-world examples, which can enhance understanding and retention. Flexibility. Online training with Proexcellency offers flexibility in scheduling, allowing you to learn at your own pace and from anywhere with an internet connection. Certification preparation. If applicable, their courses may prepare you for official certifications related to TeamCity, boosting your credentials in the job market. Support and resources. They likely provide access to resources such as study materials, forums, and support channels to assist you throughout your learning journey. Reputation. Proexcellency's reputation within the industry or among previous learners can serve as a testament to the quality and effectiveness of their training programs. Thank you.